Good morning. Can you hear me in back? Yep. So when I started to prepare for this talk, I thought I was going to give a talk on impediments or barriers to migration in giant sequoia and coast redwood, and fairly soon realized that there was probably nothing very special about either of these things. The rules seem pretty general, although there's some interesting things. So I got increasingly interested in how humans could somehow or other be involved in this business of migration. The talk sort of morphed from an overview of what was going on to a speculation about the future, and finally became what I would probably call as close to an op-ed talk. So as with most op-ed talks, you're welcome to disagree with me. I would be disappointed if you believe what I say. And finally, I would really like it if you would think about some of these topics that come up. As a background to this, we have a pretty good fossil record that says that both giant sequoia and coast redwood have been around on Earth for over 100 million years, and they've been all over the place in both hemispheres. And during that time, they've had to migrate, sometimes long distances, and probably in response to some need to migrate. And they've done so successfully for that 100 million plus years until they've landed where they are now in these fairly restricted ranges, pretty much all within California. We look at a closer time scale, let's say a couple of 100,000 years, the last couple of ice ages. Our fossil record is thinner. It mostly consists of layers of pollen, and though it can be dated. And what we've found from that is that the current range that we have on these two species, both of them have moved around a little bit in that last period. Redwood's gone south in periods that were cold, down to at least Santa Barbara and maybe as far as La Brea in the LA basin. It's gone north about halfway up the Oregon coast, and it's settled back to where it is now, where we are now, sort of in the middle of the Holocene. Giant sequoia played the game rather differently. It's pretty well stayed put in its current latitudinal range, but it's gone up and down the mountains, maybe as high as 300 meters higher about 6,000 years ago in the Holocene maximum, and down much closer to the valley bottom during the colder periods of the last couple of glacier periods. And then if we move to this very short period of time where Spaniards and Mexicans and then Americans finally got around to so-called discovering these species and have mapped them, we find that they've really pretty much stayed put. There's minor adjustments in both of them. In some places we find young trees growing out beyond the edge of the old map range, and in some places we find deep retreat where trees near the edge have pulled back. But largely they're in the same place, so that means it's probably a matter of timing rather than actually something different going on. But now we're concerned, and we're concerned about the possibility that with global warming and other changes in the environment, it may have to, or both of them may have to migrate again, and so we get down to questions that might get in the way of that migration. A big one, of course, is climate, and we put a lot of attention on that. We found out that data from the natural range, and also importantly data from trees that are planted all over the world, have us a pretty good idea of what are permissive climates, and in some places it's permissive for these trees to grow and thrive, and in other places it says they can survive but they're not going to do very well, and then a great range of climates which are going to exclude these one or both of these species from existing there. So I think we understand climate is a very important barrier to migration. And once we get into those permissive climate areas, then we run into a bunch of other things. One is simply getting there. If it's close to where we have the native range, then it becomes reasonably possible for the things to move out. And that's been kind of a curiosity, is since we are close to the native range, particularly in places like the border between Oregon and between California and Oregon, you wonder why Coast Redwood seems to get better and better as it goes farther north, and then suddenly it stops. That's been a curiosity. Zane Moore, who is here at this meeting today, has found a couple of trees out beyond that, and Zane might be an interesting person to talk to that. Are these remnants of a grove that has disappeared? Are these advanced guards for a migration north? Or are they just a couple lucky trees that happen to be able to establish? So, getting there is one thing. Establishing and growing well is the second. And then comes the problem, are they able to reproduce? Because if you can't reproduce, this is going to be a short-term event. One of the other things when they get there is they run into some sort of enemies, and a common one is a fungus or an insect. And probably an important one in both giant sequoia and coast redwood is their seedling stage is unusually susceptible to half a dozen or maybe fewer species of fungal organisms that cause damping off. So something that affects or encourages these things to be there means the seeds may arrive, but probably you won't get establishment. And then you move on up through these various things that may attack the new arrivals, and you get to, I think, one of the really important things that I think has been overlooked a lot in trying to figure out the envelope where these things may move to, and that is competition. And competition happens, as I mentioned, from the moment the seed arrives there, but probably starts with such things as grasses and other herbs. And then as the trees get bigger, to brush, and then as they get even bigger, to competing species. And important things about those competing species of trees is how quickly they can grow from seed relative to both giant sequoia and redwood, which are not very quick off the mark, on up to whether they can survive in the shade or not. And here's an important thing that I think a lot of folks in the environmental community have not yet taken aboard. Coast redwood and giant sequoia are not shade-tolerant species. The word you want to use is they can endure shade, and they will endure shade for decades, but they are not happy in shade, and neither one of them will be growing or thriving unless you give it nearly full sunlight, and they like full sunlight even better. So any species that can get above them and then continue is going to compete very well with them, and that's most of our species. So that's a list. And I think I'll sort of take a little break now and tell you a story that Jim Rydelius told me several decades ago. I don't know if Jim's in the audience, but he's here, so you can check with him if I got this right or not. Story starts about the end of the 1800s and the early 1900s, when logging was really becoming important in the North Coast. And according to Jim, it was pretty normal in those days for ranchers to move in behind clear cuts and try and convert that land into rangeland for their cattle. They did this by setting the place on fire once the logging slash had dried out enough, and then sowing grass. So what happens next? What happens next is redwood sprouts from the stumps. And you get, if the clear cut isn't so enormous, you get some seeds blowing in. A lot of Douglas fir seeds, few redwood seeds, few other things like grand fir or western hemlock or a couple of others, manage to germinate and establish in spite of the grass competition. So then these trees grow, and they grow a little more, and they grow a little more, until 2 or 3 years, or maybe 4 or 5 years later, the rancher says, those trees are taking up all my grass, and he sends out the ranch hands and they cut them all down again, and a few months later, after the wood is dried out, they set the place on fire again. So then what happens? Well, the stump sprouts, some of them are big enough, so they simply fire column from their bowls. The new seedlings of redwood probably get killed back to near ground level or so, but they sprout from the little burl that sits down on the root collar. And pretty much everybody else gets killed, all the ones that depend on seedling establishment. So then, process goes over again. Trees are growing, the rancher gets increasingly unhappy, sends his ranch hands out to cut them all down and set it on fire again, and it proceeds further. Although now, these redwoods that have good root systems and can still sprout have really got a charge, and they start growing before the next crop of seeds gets going. And what's happened is we've tipped the balance between things like Douglas fir and other things. Will beat a redwood in a fair fight, but it's not a fair fight anymore. The redwoods start to beat the other guys. According to Jim, this had an interesting consequence. Where this was tried in a lot of places, the composition of that forest had more redwoods in it after this attempt and a conversion, and by the way, eventually the rancher gives up and quits doing this, and it goes back to forest. So that new forest now has a higher proportion of redwood in it than it did before. And I think that's an interesting history of some of the land around here. So, having looked at that, it occurs to us that there are still some pretty difficult problems relative to natural migration, and particularly as people have been talking about the fact that migration may need to be faster. It doesn't happen on the same time scale that it did historically. So the question comes, now that we have humans in the picture, and particularly American humans, they do a lot of things like land conversion and urbanization and letting out greenhouse gases and that sort of thing that are pretty negative, but they can do some good things too. And a lot of our American humans have gotten on the side of redwoods and decided to try and help them. So one of the important things that is now clear is that all around the world it has been our experience that humans can successfully plant and husband redwoods in a whole lot of places. A couple of our local organizations have taken it further. Perhaps most importantly is Sierra Pacific Industries with giant Sequoia, and more modestly Archangel Ancient Tree group with Coast Redwood, is they have purposely said, we will make available and plant new plantations with the intention of having them be long-time groves. Sounds like a great idea. So this is assisted migration, and if those groves manage to reproduce successfully and naturalize, we're starting to call it assisted colonization. So is there a problem with, well, first, there's a question about this. Is if we can do this, if these friendly humans can help out this way, why do we worry about natural migration? Well, there's one question that comes to mind, and that is that humans may not continue to be able to do this. Been a long history of religious people predicting some kind of Armageddon. But in 1945, we dropped a nuclear bomb on Hiroshima, and that changed the rules. And instead of humans carrying the little end of the world signs, we now have a bunch of serious scientists that worry about this thing, and they've created a thing called the doomsday clock in terms of how many problems we're creating for ourselves, and we got a bunch of them. I'll mention this three briefly. One is that we've learned, and it's pretty natural, is that since 1945 we've understood that we got hit by an asteroid. and it pretty well took out much of life on Earth and destroyed a whole bunch of species. Second one, and this is one of the things the Union of Concerned Scientists worries about, and that is that we have now enough nuclear weapons, so if somebody makes the mad mistake of initiating an attack and whoever gets attacked makes the retaliatory hit, we're going to kill a whole lot of humans and destroy just about everything else in the process of that. Folks that worry about this, in case you read On the Beach, Neville Shute got it wrong, we think, that because most of the nuclear powers are in the northern hemisphere, the real damage is probably going to be limited to that, and the southern hemisphere will be okay. Both humans and forests that are in the southern hemisphere. How long the northern hemisphere remains uninhabitable is a good question, but we're talking at least many decades, probably centuries. So we're going to be looking at a time where a lot of folks and a lot of trees are okay, but not in the northern hemisphere. The third one, which is an interesting one, is the possibility of engineering and weaponizing a pathogen. We have the Black Plague to look back at, which for 4 centuries pretty well shook up both social and political and economic ways of being civilized. This weaponized pathogen will probably do a whole lot of better job at wiping out humans, and will probably get most of us. If it's a typical pathogen, a few of us will be resistant to it. So there we're looking at a pause of maybe a century or so while the remaining survivors build up. Well, to bring it to a quick close, what I want to end with is to say that it seems like this assisted migration thing, or assisted colonization, might be a good thing to do. We're going to hear from Bob Ewing this afternoon, who says that when we do things for redwoods, it's probably to our own benefit, and I'd like you to leave with this thought, that it seems to me, and a bunch of folks that agree with me, that redwood and giant sequoia are sufficiently attractive species that we can, through conservation and developing populations around the world that might replace what we've got here, that might be a good thing to do, whether humans survive to go appreciate them again or not. So.
Okay, my question has to do with what limits the northern distribution of the redwood. Would it possibly be frost hardiness of the seedlings? Would that be a factor?
Yeah, Stephen, for those who are mystified by this, because you're in another section, we were talking about migration and why they are where they are or not. And the question about frost hardiness is a tricky one, because a lot of frost hardiness depends on things like how deep the roots are, and that depends on what the soil type is. So, for instance, in Germany, they have found out that if you plant into a normal soil, you will frequently leave your young redwoods. On the other hand, if you plant into a hole that allows the roots to quickly go below the frost level, then they're just fine. So frost hardiness is kind of tricky. And I don't know whether we really have variability in that much, but in some trials that have been put in around the world, things from the Napa County population seems to be about the most continental of the redwood populations. And interestingly enough, those Napa County trees handle not only frost better than most of the others, but they also handle high heat better. In other words, they're just used to a more continental climate. Does that do it, Steve? Sorry.
Any other questions for Dr. Libby while he's up here?
Yeah, so I'm really interested in assisted migration. I'm from the Midwest. We could have 12 to 15 species out in our overstory. So when we start talking about assisted migration, we're trying to pick and choose a few species that will do really well in a range south of us and moving north of us. We start getting a question of, do we wait 100 years, or now we're 16 years into that 100-year estimation? Do we wait until 2100 to start planting redwood north, or do we plant redwood north now and not ready for 2100, the year 2100? Your thoughts on, do we wait and we plant?
Yeah, did everybody understand that question? Good. As I understood it, the question is, when do we do assisted migration in terms of the right time, and how smart do we have to be to do it? Let me give another plug to SPI. It is one of the decisions we came to early, and by the way, Sierra Pacific Industries is the only organization I can think of in California that is really doing aggressive assisted migration. And what they're doing is they're taking samples of each of the 75 or so groves, and then they're planting them in normally riparian areas where they wouldn't be allowed to cut anyway, and letting them grow into the indefinite future. One of the rules we put down early is we can't get too smart too quick. Because in the time scale we're looking at, we don't know if things are going to get warmer, colder, or what the heck they're going to do. So they made a real attempt to take some of the populations, samples that is, and put them in high. Some of them put them in further north. Some of them put them in lower or hotter, and trying to cooperate with the Forest Service, which isn't that hard, put them in a southern direction. And we thought that pretty well, and then they put them in a couple other places too. But we thought that pretty well covered the likely things that are going to happen in the next 2,000 years, which means a giant sequoia is about middle-aged at that time. Does that help? Yeah.